In this illustration, we are going to discuss the formula for degree of unsaturation of a compound. For this molecule, find the index of hydrogen deficiency. The solution is as follows. The concept behind the degree of unsaturation is that it refers to the number of H2 molecules required to convert the given compound into an open chain alkane, meaning the general formula as CnH2n plus 2. Using this concept in this problem, we can understand how can we deal oxygen, halogen, nitrogen and boron for converting in this to this formula. Let us start with analyzing oxygen. Just consider the conversion or the addition of an oxygen to a molecule. I am considering this carbon atom as a reference and they might be attached to any other group, this hydrogen. If I want to add an oxygen to this compound, it will be added in this way. On observation, we can clearly see that the number of hydrogen atoms remains same. Since for the addition of hydrogen, we add 0 hydrogen, therefore, if we want to remove this oxygen, we will also have to remove 0 hydrogen. Therefore, oxygen will not affect the double bond equivalent of a molecule. Next, we'll analyze the same with the halogen. If this is a halogen, this is a hydrogen, and we need to convert it to a halogen. You can clearly see for this conversion we need to remove one hydrogen. Therefore, if we need to find the corresponding hydrogen compound for a halogen, we must add one hydrogen to the molecule. This implies the halogen species is equivalent to one extra hydrogen. Similarly, analyzing nitrogen, if we want to add nitrogen, then it will be in this form, NH2. Clearly we can see here it has one hydrogen and here it is two hydrogens. Therefore, for this process we need to add one hydrogen. Therefore, if we want to find the equivalent of nitrogen in an open chain compound, we can say we need to remove one hydrogen. Therefore, nitrogen is equivalent to removal of one hydrogen. Similarly, with boron, if we analyze, boron is also a similar kind of case because it will be in the form of BH2. Therefore, again we can say for this process we need to add one hydrogen. Therefore, if we want to find the equivalent of boron, we need to remove one hydrogen. Therefore, a boron is also equivalent to a nitrogen and is equivalent to minus one hydrogen. Now, on removing the equivalents, we get a new formula to be CCHH. Since oxygen does not play any role, it does not affect the dBE of a molecule, we are ignoring it. Halogen molecule is equivalent to one extra hydrogen. Therefore, we can replace it by HX. X is the number of halogen atoms. Nitrogen, similarly, we can remove it with a minus one hydrogen. Therefore, it becomes nitrogen minus N, and similarly boron can be written as minus B. On condensing the formula, we get CCH H plus X minus N minus B. Now, an open chain alkane is having the formula of CCH2C plus 2. Therefore, the extra amount of hydrogen atom that needed to be added here is, calling delta H, can be written as 2C plus 2 minus the present number of hydrogen atoms, H plus X minus N minus B. This is the extra H atoms required. We clearly know that 2 H atoms contribute to one hydrogen molecule. Therefore, we can say 2 times the change in hydrogen will release into 1 time the change in hydrogen molecule. Therefore, delta H can be written as equal to delta H2 upon 2. Therefore, to find delta H2, we can say this whole thing we need to divide by 2. Therefore, this becomes 2C plus 2 minus H plus X minus N minus B whole by 2. On simplifying, we get the change in number of hydrogen atoms to convert it to open chain, that can be written as the degree of unsaturation or the index of hydrogen deficiency or the double bond equivalent of this molecule as C plus 1 plus half N plus B minus H minus X. This is the result of this problem and can be remembered as a standard result. That is the solution.